Hey there. Subscribe to my channel and also press this bell icon so you can get latest video notifications.
Hi my dear students, welcome to my channel. 10th standard, the chapter name is Real Numbers. So let's study the concept of Euclid division lemma in this video and let's solve some problems on it. Euclid's division lemma. The name itself says that Euclid's division lemma. So you all know the actual division of numbers, and the lemma is nothing but it is a proven statement which helps to proving the another statement. So lemma ಅನ್ನೋದು ಒಂದು ಈಕ್ವೇಶನ್ ಆಗಿರುತ್ತೆ. ಆ ಈಕ್ವೇಶನ್ ನಾವು ಇನ್ನೊಂದು ಸ್ಟೇಟ್ಮೆಂಟ್ ನ ಪ್ರೂವ್ ಮಾಡೋದಕ್ಕೆ ಈ ಈಕ್ವೇಶನ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅದಕ್ಕೆ ನಾವು ಲೆಮ್ಮಾ ಅಂತ ಕರಿತೀವಿ. Let us understand the Euclid division lemma by giving an example, that is divide 70 by 15. So let us divide 70 by 15. So we all know the division where the 70 is called the dividend. The 70 is called the dividend and the 15 is the divisor. So ನಮಗೆ division ಗೊತ್ತಾಯಿದೆ ಮಕ್ಕಳೇ. So 15 4s are 60. So 15 4s are 60 and we get the remainder as 10. We get the remainder as 10. So where we consider the 4 as quotient and the 10 as remainder. But in this Euclid division lemma, we should consider the dividend as A and the divisor as B and the quotient as Q and the remainder as R. So we can conclude that dividend as A and divisor as B and the quotient as Q and the remainder is R. In any division which must be satisfied, the Euclid division lemma, that is dividend is equal to divisor into quotient plus remainder. ಯಾವುದೇ ಡಿವಿಷನ್ ಆಗಲಿ ಮಕ್ಕಳೇ, ಆ ಡಿವಿಷನ್ ಅಲ್ಲಿ ಡಿವಿಡೆಂಡ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡಿವೈಸರ್ ಇಂಟು ಕೋಶನ್ ಪ್ಲಸ್ ರಿಮೈಂಡರ್ ಆಗಲೇಬೇಕು. ಇಲ್ಲೇ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಬೇಕಾದ್ರೆ ಡಿವೈಸರ್ ಇಂಟು ಕೋಶನ್ ಪ್ಲಸ್ ರಿಮೈಂಡರ್ 15 4s are 60 plus the remainder is 10, that is 70. Again you will get the dividend. ಅದು ಯಾವುದೇ ಡಿವಿಷನ್ ಆಗಿದ್ರು ನಿಮಗೆ ಈ ಒಂದು ಯೂಕ್ಲಿಡ್ ಡಿವಿಷನ್ ಲೆಮ್ಮ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಲೇಬೇಕು. ದಟ್ ಈಸ್ ಡಿವಿಡೆಂಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಡಿವೈಸರ್ ಇಂಟು ಕೋಶನ್ ಪ್ಲಸ್ ರಿಮೈಂಡರ್ ಆ್ಯಂಡ್ ಕನ್ಸಿಡರ್ ದ ಡಿವಿಡೆಂಟ್ ಇಸ್ ಆಸ್ ಎ. ಸೊ ಡಿವಿಡೆಂಟ್ನ ಎ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಡಿವೈಸರ್ನ ಬಿ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಕೋಶಂಟ್ ಇಸ್ ಕ್ಯೂ ಆ್ಯಂಡ್ ದ ರಿಮೈಂಡರ್ ಇಸ್ ಆರ್. Therefore the Euclid division lemma is nothing but a is equal to bq plus r. So ಇದನ್ನ ನಾವು Euclid division lemma ಅಂತ ಕರಿತೀವಿ. So that is the statement of this Euclid division lemma, that is given positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, 0 less than or equal to r less than b. So this is the statement of Euclid division lemma. Given positive integers a and b, ಅಂದ್ರೆ ಯಾವುದಾದ್ರೂ ಎರಡು ನಂಬರ್ನ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡೋಣ where a is the dividend and b is the divisor. b is the divisor. ನಾವೆರಡನ್ನು ಅದನ್ನ ಡಿವಿಷನ್ ಮಾಡಿದ್ರೆ there exist unique integers q and r, that q and r nothing but ಕೋಶಂಟ್ ಅಂಡ್ ರಿಮೈಂಡರ್. ನಾವು ಯಾವುದೇ ಎರಡು ನಂಬರ್ನ ಡಿವಿಷನ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಯುನೀಕ್ ಇಂಟೀಜರ್ ಕೋಶಂಟ್ ಮತ್ತೆ ರಿಮೈಂಡರ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಆ್ಯಂಡ್ ದೀಸ್ 4 ಕ್ವಾಂಟಿಟೀಸ್ ಮಸ್ಟ್ ಬಿ ಸ್ಯಾಟಿಸ್ಫೈಡ್. ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಬಿ ಕ್ಯೂ ಪ್ಲಸ್ ಆರ್, ದಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಡಿವಿಡೆಂಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡಿವೈಸರ್ ಇಂಟು ಕೋಶಂಟ್ ಪ್ಲಸ್ ರಿಮೈಂಡರ್. ಇದನ್ನು ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಲೇಬೇಕು ಅದು. And you observe the condition of this lemma, that is 0 less than or equal to or less than b. What is the meaning of this condition? Very important. That is the remainder is always equal to 0 or less than the divisor. ನಮಗೆ ಯಾವಾಗಲೂ ರಿಮೈಂಡರ್ ಏನಾಗಿರಬೇಕು, ಯಾವುದೇ ಡಿವಿಷನ್ ಆಗಿರಲಿ ಆ ರಿಮೈಂಡರ್ ಏನಾಗಿರಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ಅದು 0 ಆಗಿರಬೇಕು ಅಥವಾ ಡಿವೈಸರ್ಗಿಂತ ಕಡಿಮೆ ಇರಬೇಕು. ಸಪೋಸ್ ನಿಮಗೆ ನಾವು ಡಿವೈಸರ್ನ 3 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ದೆನ್ ದ ಪಾಸಿಬಲ್ ರಿಮೈಂಡರ್ಸ್ ಏನಾಗಿರುತ್ತೆ, ದೇ ಆರ್ 0, 1, 2 ಆಗಿರುತ್ತೆ. ಸಪೋಸ್ ದ ಡಿವೈಸರ್ ಏನಾದರೂ 5 ಆಗಿದ್ರೆ ನಿಮಗೆ ರಿಮೈಂಡರ್ ಏನೇನು ಸಾಧ್ಯತೆ ಆಗಿರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ 0, 1, 2, 3, 4 ಅಲ್ಲಿವರೆಗೂ ಪಾಸಿಬಿಲಿಟಿ ಇರುತ್ತೆ. ಸೊ ದ ಮೀನಿಂಗ್ ಆಫ್ ದಿಸ್ ಕಂಡೀಷನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದ ರಿಮೈಂಡರ್ ಇಸ್ ಆಲ್ವೇಸ್ ಈಕ್ವಲ್ ಟು 0 ಆರ್ ಲೆಸ್ ದೆನ್ ದ ಡಿವೈಸರ್. I hope you all understood the concept of Euclid division lemma. Let's move on to the problems. The first one is show that every positive even integer is of the form 2q and that every positive odd integer is of the form 2q plus 1 where q is some integer. ಅಂದರೆ ಎಲ್ಲ ಪಾಸಿಟಿವ್ ಈವನ್ ಇಂಟೀಜರ್ಸು 2q ಫಾರ್ಮಲ್ಲಿ ಇರುತ್ತೆ, ಎಲ್ಲ ಪಾಸಿಟಿವ್ ಆಡ್ ಇಂಟೀಜರ್ಸು 2q plus 1 ಫಾರ್ಮಲ್ಲಿ ಇರುತ್ತೆ ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಸೊ ಈವನ್ ಇಂಟೀಜರ್ಸ್ ಅಂದ್ರೆ ಏನು, ದೇ ಆರ್ ಡಿವಿಸಬಲ್ ಬೈ 2. ಆಡ್ ಇಂಟೀಜರ್ಸ್ ಅಂದ್ರೆ ಏನು, ದೇ ಆರ್ ನಾಟ್ ಡಿವಿಸಬಲ್ ಬೈ 2 ಅಂತ ಅರ್ಥ. ಲೆಟ್ ಸಾಲ್ವ್ ದಿಸ್ ಪ್ರಾಬ್ಲಮ್. ಲೆಟ್ ಎ ಬಿ ಎನಿ ಪಾಸಿಟಿವ್ ಇಂಟೀಜರ್ಸ್. ಮಕ್ಕಳು ಎ ಅಂದರೆ ಯಾವುದಾದ್ರೂ ಒಂದು ಪಾಸಿಟಿವ್ ಈವನ್ ಇಂಟೀಜರ್ ಆಗಿರುತ್ತೆ. ಈವನ್ ಇಂಟೀಜರ್ ಅಂದರೆ ಐದರ್ ಇಟ್ ಮೇ ಬಿ 2, 4, 6, 8, 10 ಎಕ್ಸೆಟ್ರಾ ಯಾವುದಾದ್ರೂ ಆಗಿರ್ಬೋದು. ಬಟ್ ಎ ಮಸ್ಟ್ ಬಿ ಎನಿ ಪಾಸಿಟಿವ್ ಇಂಟೀಜರ್ and a is also a dividend. Please do remember a is a dividend and it is any even integers. So let us consider the Euclid division lemma, that is a is equal to bq plus r, 0 less than or equal to or less than b. And we have to consider a as dividend, b as divisor, q as quotient and r as remainder. And the divisor is 2 here and let b is equal to 2. Substitute in the given Euclid division lemma, that is a is equal to b is 2 here, 2q plus r. A is equal to 2q plus r and the condition becomes 0 less than or equal to or less than 2. And the meaning of this condition is the remainder is either 0 or less than 2. ಅಂದರೆ ರಿಮೈಂಡರು 0 ಆಗಿರಬೇಕು ಅಥವಾ 2ಗಿಂತ ಕಡಿಮೆ ಇರಬೇಕು ಅಂತ. ಹಾಗಾದರೆ ಪಾಸಿಬಿಲಿಟೀಸ್ ಆಫ್ ದ ರಿಮೈಂಡರ್ಸ್ ಆರ್ ಐದರ್ 0 ಆರ್ 1 ಅಂತ. ಸೊ ಎರಡೂ ಕೂಡ ಪಾಸಿಬಿಲಿಟೀಸ್ ಇರುತ್ತೆ. ಸಿನ್ಸ್ ಎ ಇಸ್ ಎ ಪಾಸಿಟಿವ್ ಈವನ್ ನಂಬರ್, ಸೊ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಬಟ್ ಆರ್ ಇಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 1 ಅಂತ. ಅಂದರೆ ಎ ಅನ್ನೋದು ನಾವು ಡಿವಿಡೆಂಟ್ ಅಂತ ಗೊತ್ತು, ಅದು ಈವನ್ ಪಾಸಿಟಿವ್ ಇಂಟೀಜರ್. ಮುಂಚೆನೇ ಹೇಳಿದೆ ಮಕ್ಕಳೇ ನಿಮಗೆ, ಈವನ್ ಪಾಸಿಟಿವ್ ಇಂಟೀಜರ್ಸ್ 2, 4, 6, 8, 10 ಯಾವುದಾದ್ರೂ ಆಗಿರ್ಬೋದು. ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಡಿವಿಸಬಲ್ ಬೈ 2. ಡಿವೈಸರ್ ನಾವು 2 ತೊಗೊಂಡಿದ್ದೀವಿ. ಸೊ ಎಲ್ಲ ಈವನ್ ನಂಬರ್ನ ನಾವು 2 ಇಂದ ಡಿವೈಡ್ ಮಾಡ್ತಾ ಹೋದರೆ ನಮಗೆ ರಿಮೈಂಡರ್ 0ನೇ ಬರ್ತಾ ಹೋಗುತ್ತೆ, 1 ಬರೋ ಸಾಧ್ಯತೆ ಇರಲ್ಲ. ಸೊ ದೇರ್ ಫೋರ್ ಆರ್ ಇಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 0. Therefore, if r is equal to 0, substitute here a is equal to 2q plus 0. R is equal to 0. Therefore, 2q plus 0 is a is equal to 2q, where a is nothing but positive even integer. Therefore, we can conclude that every positive even integer is of the form 2q. I hope you all understood the half of the statement. So we'll prove the next half of the statement, that is every positive odd integer is of the form 2q plus 1. ಇದೇ ತರ ಸಾಲ್ವ್ ಮಾಡೋಣ ಮಕ್ಕಳೇ. Let a be any positive odd integer. So let us consider a as any positive odd integer, which means a must be either 1, 3, 5, 7, 9, 11 ಎಕ್ಸೆಟ್ರಾ ಅದು ಯಾವುದಾದ್ರೂ ಆಗಿರ್ಬೋದು. ಆದರೆ ಎ ಅನ್ನೋದು ಪಾಸಿಟಿವ್ ಆಡ್ ಇಂಟೀಜರೇ ಆಗಿರಬೇಕು. ಆ್ಯಂಡ್ ಎ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಡಿವಿಡೆಂಟ್. ಸೊ ಅಗೇನ್ ಬೈ ಕನ್ಸಿಡರಿಂಗ್ ದ ಯೂಕ್ಲಿಡ್ ಡಿವಿಷನ್ ಲೆಮ್ಮ, ದಟ್ ಈಸ್ ಎ ಈಸ್ ಈಕ್ವಲ್ ಟು ಪಿ ಕ್ಯೂ ಪ್ಲಸ್ ಆರ್, 0 ಲೆಸ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಆರ್ ಲೆಸ್ ದೆನ್ ಬಿ. ಸೊ ನಿಮಗೆ ಯೂಕ್ಲಿಡ್ ಡಿವಿಷನ್ ಲೆಮ್ಮ ಗೊತ್ತಿದೆ ಮಕ್ಕಳೇ, ಅದನ್ನು ಬರ್ಕೊಳ್ಳೋಣ. ಆ್ಯಂಡ್ ದ ಡಿವೈಸರ್ ಇಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ 2 here. Let b is equal to 2. Substitute here. A is equal to 2q plus r. b becomes 2 here. A is equal to 2q plus r. And the condition becomes 0 less than or equal to or less than 2. Therefore, the remainders are possibilities 0 or 1. ಹಾಗಾದರೆ possibilities of remainders ಏನಾಗಿರುತ್ತೆ? Either 0 or less than 2, that is nothing but 0 and 1. Since a is positive odd integer, ಏನದು ಪಾಸಿಟಿವ್ ಆಡ್ ಇಂಟೀಜರ್ ಆಗಿರೋದ್ರಿಂದ ನೀವು ಯಾವುದೇ ಆಡ್ ನಂಬರ್ ತಗೊಳ್ಳಿ, 3, 5, 7, 9 ಯಾವ್ದಾದ್ರು ನಂಬರ್ ತಗೊಳ್ಳಿ, 2 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿ. ಸೊ ನೀವು ಯಾವುದೇ ಆಡ್ ನಂಬರ್ನ 2 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ರಿಮೈಂಡರ್ 1 ಉಳಿತಾ ಹೋಗುತ್ತೆ. And the remainder is not equal to 0. If any odd number is divisible by 2, then the remainder is 1, but r is not equal to 0. And r is equal to 1, substitute here. Therefore, a is equal to 2q plus 1. r is 1 here. Therefore, where a is nothing but positive odd integer and it is in the form of 2q plus 1. I hope you all understood this problem. We'll move on to the next problem. Show that any positive odd integer is of the form 4q plus 1 or 4q plus 3 where q is some integer. Makla ಇಲ್ಲಿ any positive odd integer is also in the form of 4q plus 1 or 4q plus 3. In the previous problem, we have proved that any positive odd integer is of the form 2q plus 1. But any positive odd integer is also in the form 4q plus 1 or 4q plus 3. Here we have to consider the divisor as 4. So let's solve the problem. Let a be any positive odd integer, which means positive odd integer means nothing but 1, 3, 5, 7, 9, 11, etc. So a must be a dividend and it must be any positive odd integer. And by considering the EDL, that is Euclid division lemma, a is equal to bq plus r, 0 less than or equal to r less than b. This is the condition and this is lemma. Let us consider the divisor. ಈಗ ನಾವು 4ನ ಡಿವೈಸರ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ. Therefore, the Euclid division lemma becomes a is equal to 4q plus r. Therefore, b becomes 4 here, 4q plus r, 0 less than or equal to or less than 4. And you all know the condition, that is the remainder is either equal to 0 or less than 4. ಅಂದರೆ ರಿಮೈಂಡರ್ ಅನ್ನೋದು ಏನಾಗಿರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅದು ಯಾವಾಗಲೂ 0 ಆಗಿರಬೇಕು ಅಥವಾ ಡಿವೈಸರ್ಗಿಂತ ಕಡಿಮೆ ಇರಬೇಕು. 4ಕ್ಕಿಂತ ಕಡಿಮೆ ಅಂದರೆ therefore the possibilities of remainder ಏನಾಗಿರುತ್ತೆ? Therefore the possible remainders are 0, 1, 2 or 3. These 4 are the possibilities of remainder when you consider the divisor as 4. ನೀವು ಡಿವೈಸರ್ನ 4 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ then the possible remainders are 0, 1, 2, 3. Since a is any positive odd integer, ಪಾಸಿಟಿವ್ ಆಡ್ ಇಂಟೀಜರ್ ಅಂದ್ರೆ ಏನು? ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 5 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಾ. 5 ಅಂತ ಆಡ್ ನಂಬರ್ ತಗೊಂಡ್ರೆ ನೀವು 4 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ರಿಮೈಂಡರ್ ಏನು ಬರುತ್ತೆ? ಇಫ್ ಯು ಡಿವೈಡ್ 5 by 4, 5ನ ನೀವು 5 ಅನ್ನೋದು ಆಡ್ ಇಂಟೀಜರು 4 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ರಿಮೈಂಡರ್ 1 ಉಳಿಯುತ್ತೆ. ಅದೇ ನೀವು 7 ಅಂತ ತಗೊಳ್ಳಿ, ಇಫ್ ಯು ಕನ್ಸಿಡರ್ ದ 7 as ಆಡ್ ಇಂಟೀಜರ್ 4 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿ, ಆವಾಗ ನಿಮಗೆ ರಿಮೈಂಡರ್ 3 ಉಳಿಯುತ್ತೆ. ಸೊ ಸಿಮಿಲರ್ಲಿ 9 ತಗೊಂಡ್ರೆ, ಸೊ ಇಫ್ 9 is divisible, if 9 is divided by 4, then the remainder is 1. And similarly the 11 is divided by 4 and the remainder is 3. Therefore, for every odd integer divisible by 4, you will get the remainder as 1 and 3 only. ಅಂದರೆ ಮಕ್ಕಳೇ, ನೀವು ಯಾವುದೇ ಆಡ್ ನಂಬರ್ನ 4 ಇಂದ ಡಿವೈಡ್ ಮಾಡ್ತಾ ಹೋದರೆ ನಿಮಗೆ ಪಾಸಿಬಲ್ ರಿಮೈಂಡರ್ಸ್ 1 ಬರ್ತಾ ಹೋಗುತ್ತೆ ಮತ್ತು 3 ಬರ್ತಾ ಹೋಗುತ್ತೆ. 0 ಮತ್ತೆ 2 exist ಆಗಲ್ಲ. Therefore we cannot consider these two. If the remainder is 1, substitute here. If r is equal to 1 ಆದರೆ a is equal to 4q plus 1 ಆಗುತ್ತೆ. ಸೊ ಮೊದಲನೇದು ಪ್ರೂವ್ ಆಯಿತು. If r is equal to 3 ಆದರೆ if r is equal to 3 then a is equal to 4q plus 3 ಆಗುತ್ತೆ. That is a is equal to 4q plus 3. Hence proved. Therefore every positive odd integer is also in the form of 4q plus 1 or 4q plus 3. Hence proved. The next problem. Show that any positive odd integer is of the form 6q plus 1, 6q plus 3 or 6q plus 5 where q is some integer. Here we have to consider the dividend a as positive odd integers and the divisor as 6 here. Let a be any positive integer, as we all know that. So positive integers are 1, 3, 5, 7, 9, 11, etc. So therefore a is a dividend and it may be any positive odd integers. By Euclid's division lemma, that is a is equal to bq plus r, 0 less than or equal to r less than b. You all know the Euclid division lemma and write here. And we have to consider the divisor as 6, that is b is equal to 6. Then the lemma becomes a is equal to b is 6 here, that is a is equal to b 6q plus r, 0 less than or equal to 6. Therefore in this condition we can understand that the possibilities of the remainders either equal to 0 or the less than the 6, which means ಆ ರಿಮೈಂಡರ್ ಏನಾಗಿರುತ್ತೆ 0 ಆಗಿರಬೇಕು ಅಥವಾ 6 ಗಿಂತ ಕಡಿಮೆ ಆಗಿರಬೇಕು ಅಂತ. ಹಾಗಾದ್ರೆ ಪಾಸಿಬಲ್ ರಿಮೈಂಡರ್ಸ್ ಏನಾಗಿರುತ್ತೆ? The possible reminders are either 0, 1, 2, 3, 4 or 5. So these 6 are the possibilities of remainder when you consider the divisor as 6. So divisor na 6 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ up to 0 ಇಂದ 5 ವರೆಗೂ ನಿಮಗೆ ರಿಮೈಂಡರ್ ಪಾಸಿಬಿಲಿಟೀಸ್ ಇರುತ್ತೆ ಅಂತ. ಅದು ಯಾವುದಾದ್ರೂ ನಂಬರ್ ಆಗಿರ್ಬೋದು. Since a be any positive odd integer, so odd integer ಆಗಿರೋದ್ರಿಂದ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಆಡ್ ಇಂಟೀಜರ್ 7 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ. 7 ನೀವು 6 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ರಿಮೈಂಡರ್ 1 ಬರುತ್ತೆ. 6 1 6 ರಿಮೈಂಡರ್ 1 ಬರುತ್ತೆ. ಅದೇ 7 ಬದಲು ನೀವು 9 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಇಫ್ ಯು ಕನ್ಸಿಡರ್ 9 ಆಸ್ ಆಡ್ ಇಂಟೀಜರ್ and divisible by 6 and you will get the remainder is 3. ನೀವು 9 ನ ನೀವು 6 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ 3 ರಿಮೈಂಡರ್ ಉಳಿಯುತ್ತೆ. ಸಿಮಿಲರ್ಲಿ 11 ನ ಆಡ್ ನಂಬರ್ ಕನ್ಸಿಡರ್ ಮಾಡಿ and it is divided by 6, you will get the remainder is 5. 6 1 6, remainder is 5. Therefore what we can conclude that if you consider any positive odd integer is divisible by 6, then the possible remainders exist only 1, 3 or 5. 0, 2 or 4 will not exist. If you divide any odd integer by 6, there exists 1, 3, 5. If r is equal to 1, then the lemma becomes a is equal to 6q plus 1. If r is equal to 3 anta consider madre, then the lemma becomes a is equal to 6q plus 3. 6q plus 3. If r is equal to 5, then the lemma becomes a is equal to 6q plus 5. Therefore, hence proved that any positive odd integer where a is nothing but any positive odd integer and they are in the form of 6q plus 1 or 6q plus 3 or 6q plus 5. Hence proved. I hope you all understood this problem. We'll move on to the next one. Use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. We should consider a as only positive integers, not even or odd. It may be 1, 2, 3, 4, 5, 6, etc. Anything, it must be any positive integer. Therefore, let A be any positive integer. So A is any positive integer. By Euclid division lemma, A is equal to BQ plus R, 0 less than or equal to or less than B. Let B is equal to 3. Let us consider the divisor. So ಈಗ ನಾವು divisor na 3 ಅಂತ consider ಮಾಡೋಣ. Therefore the lemma becomes A is equal to 3Q plus R, 0 less than or equal to R, less than 3. According to this condition, we can conclude that the remainder is either equal to 0 or the less than the 3. Therefore, the remainder ಅನ್ನೋದು 0 ಆಗಿರುತ್ತೆ ಅಥವಾ 3 ಗಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ. That is 0, 1, 2 are the possible remainders. So all the 3 possible will exist since A is any positive integer. Therefore, R possibility exists all these 3. If R is equal to 0, the lemma becomes A is equal to 3Q plus 0. That 3Q plus 0 is nothing but 3Q. Therefore, A is equal to 3Q. What is A here? A is nothing but positive integer. A is nothing but positive integer. But in the question, you may observe that square of any positive integer, but here A is a positive integer. We have to squaring on both sides. We'll get A square is equal to 3Q the whole square, where 3Q the whole square is nothing but 3 square is 9, Q the whole square is nothing but Q square. And this 9Q square can be splitted as 3 into 3Q square. If you multiply, you will get the same 9Q square. That is 3 into 3 is 9. So 3 into 3Q square. This can be written in the form of 3 into 3Q square. And this bracket part is considered as M. Therefore, it becomes 3M. This 3Q square is considered as M here. Therefore, any positive, the square of positive integer is of the form 3M. So we have proved the first one. We'll see the next one. If R considered as 1 here, then A is equal to, the lemma becomes 3Q plus 1. Question ಅಲ್ಲಿ ನಮಗೆ square of any positive integer. Therefore, the squaring on both sides, that is A square is equal to 3Q plus 1 the whole square. 3Q plus 1 the whole square. It is in the form of A plus B whole square. That is A square plus 2AB plus B square. That is A square is 3Q the whole square is 9Q square. 2AB, 2 into 3Q into 1 is 6Q plus 1 square is 1 here. If you take 3 common in the first 2 terms, you'll get 3 common ತೆಗೆದ್ರೆ 3Q square here, 3 3s are 9, 3 2s are 6. So 2Q is a remaining here. Therefore, consider this bracket part as M. ಇದನ್ನು M ಅಂತ consider ಮಾಡಿ. So 3M plus 1, where M is nothing but 3Q plus 2Q. So second one ನಮಗೆ prove ಆಯಿತು. Let's see the third one. If R is equal to 2, A is equal to 3Q plus 2 ಆಯಿತು. So lemma ನಮಗೆ 3Q plus 2. We have to square on both sides because the square of any positive integer ಅಂತ ಹೇಳಿದರೆ. So squaring on both sides, again A plus B whole square is A square, 3Q the whole square is 9Q square plus 2 into 3Q into 2 is 12Q plus 2 square is 4. So consider this 4 as 3 plus 1. So 4 can be written as 3 plus 1. So take 3 common in these 3 terms. In the first 3 terms, take 3 common here. Therefore, if you take 3 common here, so 3Q square plus 3 4s are 12, 4Q plus 3 1s are 3. So consider this bracket part as M. Therefore 3M plus 1. Therefore M is equal to 3q square plus 4q plus 1. Hence, we can conclude that square of any positive integer is of the form either 3m or 3m plus 1. I hope you all understood this problem. We'll move on to the next one. Use Euclid division lemma to show that the cube of any positive integer is either of the form 9m, 9m plus 1 or 9m plus 8. ಮಕ್ಕಳ ಇಲ್ಲಿ ನಾವೇನು ತಗೋಬೇಕು? A is considered as positive integer. So where A is nothing but dividend and it is considered as any positive integer, that is nothing but 1, 2, 3, 4, 5, 6 etc. And you all know that Euclid's division lemma, that is A is equal to BQ plus R, 0 less than or equal to or less than B. Most importantly, to this problem, we should not consider this 9 as B. Divisor na ನಾವು 9 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬಾರ್ದು. ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ, if you consider 9 as divisor, then the possible divisor becomes 0 to 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Up to 9 possibilities ಆಗುತ್ತೆ. ಅಷ್ಟು ಪಾಸಿಬಿಲಿಟೀಸ್ನ ನಾವು ಚೆಕ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. Therefore, we should consider the divisor as 3. ಇಲ್ಲೂ ಕೂಡ ಈ ಪ್ರಾಬ್ಲಮ್ಗೂ ಕೂಡ ನಾವು 3 ಅಂತಾನೆ ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೋದು. ಬಿಕಾಸ್ ಕ್ಯೂಬ್ ಆಫ್ ಪಾಸಿಟಿವ್ ಇಂಟೀಜರ್ಸ್ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಸೊ ನಾವು ಕ್ಯೂಬ್ ಆಫ್ ಪಾಸಿಟಿವ್ ಇಂಟೀಜರ್ಸ್ ಅಂತ ಹೇಳಿದ್ರೆ 3ನ ಕ್ಯೂಬ್ ಮಾಡಿದ್ರೆ ನಮಗೆ 27 ಬರುತ್ತೆ. ಸೊ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಎಕ್ಸ್ಪ್ರೆಸ್ಡ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ 9. ಸೊ ಅದಕ್ಕೆ ನಾವಿಲ್ಲಿ ಬಿನ ನಾವು 3 ಅಂತಾನೆ ಕನ್ಸಿಡರ್ ಮಾಡೋಣ. ಸೊ 9 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅಪ್ ಟು 9 ಪಾಸಿಬಿಲಿಟೀಸು ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಸೊ ಅದಕ್ಕೆ ನಾವಿಲ್ಲಿ ಬಿನ 3 ಅಂತಾನೆ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. Then the lemma equation becomes A is equal to 3q plus R, 0 less than or equal to or less than 3. So the meaning of this condition is the remainder is either equal to 0 or less than 3. That is, the possibilities of remainders are 0, 1 or 2. If R is equal to 0, then the lemma becomes 3q plus 0 is 3q. Since the question is cube of any positive integer, A is nothing but positive integer. So cube of positive integers ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Therefore cube ಮಾಡ್ಕೊಳ್ಳಿ. That is cubic on both sides. A cube is equal to 3q the whole cube. So 3 cube is 27. So q the whole cube is q cube. So and it can be written in the form of 27, 9 3s are 27. So it can be written in the form of 9 into 3q cube. Consider this bracket part into m. Therefore it becomes 9m, where m is 3q cube. Therefore any positive cube of any positive integer is of the form 9m. So let's prove the remaining 2, that is 9m plus 1 or 9m plus 8. By giving the remainder as 1 and 2. If R is equal to 1, then the lemma becomes 3q plus 1. 3q plus 1. So cubic on both sides, because cube of any positive integer, A andre positive integer, cube of any positive integer, that's why we have to cubic on both sides. So 3q plus 1 the whole cube, that is a plus b whole cube. What is a plus b whole cube? A cube plus b cube plus 3ab into a plus b, or a cube plus 3ab into a plus b plus b cube. So a cube 3q cube, 3q the whole cube plus 3 into 3q into 1 into 3q plus 1 plus 1 cube. So 3q the whole cube is 27q cube. 3 3s are 9q, 9q 1s are 9q. So 9q into 3q is 27q square. So 9q 1s are 9q. 1 cube is nothing but 1. So take 9 common in these 3 terms. You'll get, if you take 9 common here, so 9 3s are 9 into 3q cube. 9 3s are 3q square. So 9 1s are so it becomes q. Consider this bracket part as m here. Therefore, a cube is equal to 9m plus 1, where m is nothing but 3q cube plus 3q square plus cube. Similarly, if you put r is equal to 2, then the lemma becomes a is equal to 3q plus 2. So let's cubic on both sides. A cube is equal to 3q plus 2 the whole cube, and you all know that a cube plus 3ab into a plus b plus b cube. A cube is 3q cube plus 3 into 3q plus 2 into 3q plus 2 plus 2 cube. 3q the whole cube is nothing but 27q cube. So 3 3s are 9, 9 2s are 18, 18q. So 18q into 3q is 54q square. 18q into 2 is 36q plus 2 cube is nothing but 2 into 2 into 2, that is 8. So take 9 common here. So if you take 9 common, so 9 3s are 27, 3q square, 9 6 are 54, 6q square, 9 4s are 36, 4q. Therefore, consider this bracket part as m. Therefore, the cube of any positive integer is of the form 9m plus 8, where m is nothing but 3q cube plus 6q square plus 4q. Therefore, the cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. I hope you all understood these problems on Euclid division lemma. Thank you so much. ನನ್ನ ಚಾನಲ್ನ ಯಾರು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿಲ್ಲ ಅಂದರೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಬೆಲ್ ಐಕಾನ್ನ ಕ್ಲಿಕ್ ಮಾಡಿ. ಸೊ ನಿಮ್ಮ ಕಮೆಂಟ್ಸ್ನ ಕಮೆಂಟ್ ಬಾಕ್ಸ್ನಲ್ಲಿ ಕಮೆಂಟ್ ಮಾಡಿ. ನಾನು ನೆಕ್ಸ್ಟ್ ವೀಡಿಯೋದಲ್ಲಿ ಅದನ್ನು ನಿಮಗೆ ಅಪ್ಡೇಟ್ ಮಾಡ್ತೀನಿ. ಥ್ಯಾಂಕ್ ಯು ಮಕ್ಕಳೇ.